right, today we're jumping right into the fascinating and super important link between agriculture and our environment. We're going to look at the impact modern farming has and explore some of the smart solutions for a more sustainable future. This is a huge topic for your IGCSE Environmental Management course, so let's get into it.
So, here's how we're going to break it down. First, we'll get a handle on agriculture's environmental footprint. Then, we'll zoom in on one of the biggest problems it can cause, soil erosion. After that, we'll look at some of the really brilliant methods farmers use to protect our soil. And finally, we'll pull it all together to see what farming for the future really means.
Let's dive right in. Feeding everyone on the planet has meant we've had to get really good at farming on a massive scale. But pushing for those bigger and bigger yields, well, it comes at a cost to the environment. And that's what we're going to unpack now. Just look at this picture. It really gives you a sense of the incredible scale we're talking about with modern commercial farming. So when you see this, you have to ask, what are the ripple effects? Let's start with a big one. What happens when chemicals from these farms get where they're not supposed to go? Okay, here's a word you're definitely going to want to have in your back pocket. Eutrophication. It sounds complicated, but the idea behind it is actually pretty straightforward. It's what happens when too many nutrients, usually from fertilizers, wash into our rivers and lakes. And trust me, it's not a good thing. The consequences can be absolutely devastating for aquatic life.
And this is what it looks like in the real world. A river literally choking under this thick, green carpet of algae. This is called an algal bloom, and it's the most obvious sign that eutrophication is happening.
So how does a beautiful river turn into, well, that? It's a chain reaction. It all starts when fertilizer runs off the fields into the water. The algae in the water think this is an all-you-can-eat buffet, and their population explodes. That's the bloom. But that thick layer blocks sunlight, so plants in the riverbed die. Then, bacteria move in to decompose all that dead algae, and these bacteria use up a ton of oxygen. And here's the final blow. With no oxygen left, fish and other animals suffocate. It creates what's known as a dead zone. Now, it's not just fertilizers causing problems. Take a look at this diagram. It shows another huge issue that comes from mismanaging water. If you use too much irrigation, you can get waterlogged soil, which basically drowns the plant roots. Or you can get salinization. That's where the water evaporates but leaves all its dissolved salts behind, creating this crust of salt that's toxic for plants. And the list goes on. Think about those massive tractors. Their weight causes soil compaction, literally squishing the life out of the soil by squeezing out air and water pockets that roots need. If you grow the same crop over and over, you get mineral exhaustion, basically stripping the soil of its nutrients. And sometimes, we're so efficient we create another problem, overproduction, which means all the water, fuel, and fertilizer used to grow that extra food goes to waste.
Okay, so we've seen a few of these big impacts. Now let's zero in on one of the most serious threats out there, soil erosion. We're talking about the slow, silent loss of the very thing that grows our food.
So what exactly is soil erosion? Let's get a clear definition down. It's the wearing away and removal of topsoil. And that's the key word, topsoil. That's the dark, rich, fertile layer packed with nutrients. When wind or water carries that away, we're losing our most valuable agricultural asset. You really can't get a clearer picture than this. On the left, you see healthy land covered in plants. The roots act like a net, holding the soil together, while the leaves shield it from heavy rain. But on the right, with no plant cover, the soil is totally exposed, just waiting to be washed or blown away.
So, what are we doing that makes this happen so much faster? Well, the main culprits are right here. Clearing land for crops is a big one. Overgrazing is another, when you have too many cattle or sheep eating every last bit of grass. And of course, deforestation, clearing entire forests for farmland. As soon as that soil is bare, it's completely vulnerable to the forces of wind and water.
And the fallout from this? It's pretty serious. Obviously, you lose farmland, which can eventually lead to desert-like conditions. That eroded soil has to go somewhere, right? It ends up in rivers, choking them in a process called silting. And finally, when you lose that topsoil, you lose the habitat for countless organisms, which means a big hit to biodiversity. Okay, so that's the problem. It's a big one. But the good news is, we're not helpless. Farmers have come up with some really clever ways to fight back and protect our precious soil. Take a look at this. This is a classic example of terracing. It's an ancient technique where farmers cut these step-like platforms into steep hillsides. It basically turns an unusable slope into a series of flat, farmable gardens and, most importantly, stops the soil from just washing down the hill.
So how does it actually work? It's pretty simple, really. Each one of those flat terraces acts like a brake, slowing the water down as it runs downhill. Instead of turning into a powerful soil-stripping flood, the water pauses on each step, giving it time to soak into the ground, where the crops can actually use it.
All right, here's another brilliant idea. Contour plowing. You see how the rows curve with the shape of the land? That's the key. Instead of plowing straight up and down a slope, which would basically create little water slides for erosion, farmers plow along the land's natural contours.
And the logic here is genius in its simplicity. Every single one of those furrows acts like a tiny dam. It catches rainwater, stopping it from gathering speed and washing away that valuable topsoil. It's a super effective method for gentler slopes.
So you're probably noticing a pattern here, right? The big idea behind a lot of these solutions is just keep the soil covered. Windbreaks are rows of trees that act like a wall to slow down the wind. Cover crops are plants like legumes that get planted in the off-season so the soil is never left bare. And just planting more trees in general is a win-win. Their roots bind the soil and their leaves soften the impact of rain. Okay, so we've looked at the problems and we've seen some individual fixes. But for our last section, let's zoom out and put all the pieces together. The real goal isn't just patching up single problems, it's about building a whole system of farming that can last for the long haul.
So you hear this term all the time, sustainable agriculture. But what does it actually mean? Well, it's about hitting 4 targets at once. First, it has to feed us all. Second, it has to be smart with resources like water and soil. Third, it needs to support natural ecosystems, not destroy them. And finally, and this is crucial, it has to actually work for farmers, allowing them to make a decent living. It's about finding that perfect balance.
And here's a great example of that in action: mixed cropping. Instead of planting a huge field of just one thing, you grow different plants together. This is great for soil health, and it also acts as an insurance policy. If one crop fails due to pests or disease, the farmer doesn't lose everything.
And this is just one piece of the puzzle. There are a bunch of other strategies that all fit into the sustainable system. Things like using organic fertilizers to build up the soil instead of just adding chemicals. Practicing managed grazing to keep livestock moving so they don't destroy the pasture. Harvesting rainwater so you're not just relying on rivers or groundwater. And crop rotation, changing what you plant in a field each year to naturally restore nutrients.
And that leaves us with the big final question. We have the knowledge, we have these amazing techniques, but the challenge is absolutely massive. How do we take these sustainable methods and scale them up so we can feed a global population that's heading towards 8 billion people and beyond, all while protecting the planet for everyone who comes after us? That's really the central question we're facing in environmental management today.